Welcome, everybody. Thank you, 5803, for joining us. You got Apex Robotics from SeaTac. That's near Seattle, Washington. Why don't you guys introduce yourselves for the rest of the crew?
Sure. I'm Evan Morrison. I'm one of the lead mentors for Apex Robotics.
Hello, I'm Landon Lively. I'm one of the student leads on the team.
And I'm Luke, and I just do mechanical stuff.
Cool. Well, good to meet you all. Thank you for joining us tonight. So let's get started right away. So week 3 happened.
Yep.
Normally, this is when, as we said before, people start moving from prototype into design and build. It looks like that's you guys. Why don't you give me the overall rundown of what you did this week?
So this week we were finishing up our prototyping. As you see behind us, we have our finalized rude design of what our shooter will look like. We were looking at doing a linear shooter, and we went from having it dual wheeled, 2 wheels next to each other, to just a single wheel. And that took away the gap in the middle of the 2 stages, which we were realizing we were just it was an inconsistency on for the balls when we were shooting into the boiler. So that was one thing we looked at doing. We also prototyped a few more kind of geometries for the hopper, and we did a few more things with our gear pickup.
And CAD.
Okay.
Oh yeah, and CAD.
Did a lot of CAD. This guy did a lot of CAD.
So that brings us perfectly into our next sort of part. So we heard about all the different things you've done. How do you guys manage the process of moving from prototypes into actual parts? We know that you've used your prototypes. We'll talk about that in a little bit, but let's talk about the overall process. How do you guys do the CAD and all that fun stuff?
So what we really like to do at this team is we generally do all of our prototyping, design work out with the team and so forth during the meeting. But we do all of our CADing outside of the actual meetings on a program called Onshape, which allows us to have many members on our team working on different parts of the CAD all at the same time. Then we can easily Skype each other and just work out any kinks we run into, and so forth. So
can we go into that a little bit? You said that during your meetings, I saw a ton of activity. I know you guys don't meet every day of the week. I saw a ton of activity, building a lot of stuff, a lot of different prototypes coming together, and you do your CAD completely outside of all that, completely outside of meetings. Is that what led you down that path? Was it just a time thing, or what was it?
Some of it's a time thing. A lot of it is just that it's because we're using Onshape, it tends to work a little bit better to have people working just on their own computers. Onshape's an in-browser CAD program. And so it's a little bit harder at the meeting because not all the students bring their computers with them, et cetera. And we don't have a whole bank of CAD computers or something that we can access.
Okay.
But the other is, and this is something that we picked up last year just kind of by accident and really liked, is this sort of concept of CAD and validate. So we'll take a concept and we'll start doing a detailed CAD of it, and when we settle on some geometry, then we'll spend the next meeting trying to validate that geometry is functional or figure out what it should be, and then we go back and do the details or adjust it. And so what we're able to do is end up with not only a pretty complete CAD model by the end of the week, but we also have it mostly fully validated in terms of all the mechanisms working.
Oh, that's very cool. I like that. That's a pretty smart system, kind of paralleling all your processes instead of having one bottleneck. Very cool. All right, so we've heard about how this all works, and we see a lot of different prototypes in the video, and one directly behind you. So let's talk about that a little bit. Let's start with not the one behind you. Let's start with the one we saw in the video. A couple of hoppers looks like they're doing pretty good. Do you guys want to talk about that a little bit?
Okay, so for the hopper, we originally started out with kind of just a flat, hopper just to see how the balls coming from the hopper on field hopper, and how they would drop into well, our team calls the fuel tank.
Oh, right. Yes, I forgot about that.
And after we got to see how that geometry works, and then how just kind of how all the balls start to fall and so forth, we started messing around more with the geometry and making it to where it had the curves and everything to allow the balls to first get into the hopper, but then also all funnel down towards our shooter or the pickup to get to our shooter.
Okay, very cool. So, how did that all go? Like, it looks like you guys have a few different designs. Do you think you've settled on what you want to do for real?
Yeah, and that was one of the big things that we had at yesterday's meeting. Is we had what got cut off at the end of the video is what we call the magic carpet, and it's the device that takes the balls from the hopper, serializes them, so puts them all in single file to go into the shooter. And so we had that prototyped full CAD spec mock-up, and then at the last meeting we merged that with the hopper, or with the fuel tank, with the funneling, and kind of ran that whole system. So that was really cool to see. And yeah, we've basically now been able to validate that geometry functions the way we want it to, or at least close enough for us to move forward.
Actually, why don't we just, because I really want to see this, let's go to the magic carpet really quick. Hopefully this doesn't blast everybody's ears. So hold on, we're going to just swap over to the magic carpet. There we go.
There we go.
I see. Okay, cool. So we saw that there. Very cool stuff. Are you guys trying to be cool and cover up your robot as well with the magic carpet? Or
we want to be like the big boys.
Cool. All right. So now that we've got the magic carpet out of the way, let's talk about the 35-pound elephant in the room, which is that shooter behind you. Who wants to talk about a little bit more about that? I know that it was kind of a retrofit from your Party Parrot prototype, or a pre-season robot. Let's see what it's at. What's it doing these days?
Well, so first off, we had to change the wheels. We tried Colin's Andy Mark black flex wheels and blue Fairlane wheels, and we ended up going with the blue Fairlane wheels because they were single wide and there was no gap in the middle, which once again helped with the consistency. And we got a 1.5 compression off of those. And we haven't tried shooting at rate yet, but the software team is still working on getting the encoder and control loops running.
Okay, cool. So how wide is this one wheel that you guys have going? Is it super duper narrow, or is it pretty wide?
Do you want to pick it up and show them?
Yeah, let's see it.
Yeah, it's I think it's almost 2 inches wide. It's the 1 and 15/16.
Oh my God, that's a
4-inch
big
diameter blue Fairlanes. Yeah, it's a little bit clunky, but here, can you rotate this towards the camera a little bit more?
Yeah,
maybe.
Don't spin the wheel. Rotate the prototype. There we go.
There we go.
Oh, very cool.
Yeah,
right down the belly of the beast.
right down the middle.
So, do you guys want to talk a little bit more about why you thought that putting a single wheel worked better? I know, Landon, you mentioned that it was getting rid of the gap in between the wheels. Why don't we talk a little bit more about that?
Do you know why? Do you have any thoughts?
I wasn't.
We haven't talked about it. We haven't talked about it very much. Okay. We have a theory, which is that when you've got the gap in the middle, you're getting edge contact on the ball, and because the fuel has holes in it, it's not a consistent diameter, and so depending on exactly where the fuel is when it hits, it may or may not hit one of the holes.
I see.
We haven't done any high-speed video. We don't really know that that's really what's happening, but the no gap worked better than the gap, so that's what we're going with.
Very cool. All right, so it looks like it's powered by 2 sims. Is that going to be your final power system, or are you guys using some smaller motors?
So we're planning on using 2 775s.
Okay.
And we're actually looking at making it maybe a little bit more versatile, to where one may be powering our back wheel while the other one's powering the front, or we can also make it to where both of them are powering both wheels. Therefore, we can try to make the wheels keep up the consistency of keeping up the same RPM while they're shooting multiple balls at once into the boiler.
Cool. So that's going to require some more testing probably when those motors come in and the final design?
Yeah, so it really, this is kind of as far as this prototype will go.
Yeah.
Again, we used an old shooter design that we had, and so we're able to play with compression and wheel size, but we can't adjust it much more than that. So we just designed in variability, or not variability, but adjustability into the final design so that we can, as Landon said, either have both motors powering all the wheels mechanically connected or separate them out, and we'll just kind of play around with it once we have it built and see how it works.
Cool. All right, so let's kind of talk a little bit different about this. We saw a rolling part of your robot on the video. It looked like a drivetrain, but it looked, I got to say, it looked a little bit goofy. You got 3 sims, but they're mini sims.
They are mini sims.
And it looks like that's like it looks like it's VersaRail, but it's had some custom machining. Why don't you guys tell us the story behind your drive rail or your drive frame this year?
You designed it.
Oh.
So our drivetrain this year, we decided to go gears and box tubing, and then we have our chain on the outside right here, and it allowed us to get it extremely small and compact, which allows us to make our robot extremely small, which is also allowing us to have less weight. Less weight equals faster, and then also that may allow us to possibly flying faster. Who knows? Now going on to why we have 3 mini sims. During the summer, a document came up that we came aware of where they actually did testing of the power and everything for a mini sim, a sim, and then a few other motors. And it actually was shown that mini sims are 3 mini sims are actually more powerful than 2 mini sims, are more efficient, and they get power quick, speed quicker.
They're a little bit better thermally when they heat up, and this is based off of, as he said, the VexPro motors.vex.com data. And so we looked at that and said, well, at the end of the match, we had thermal problems last year with our sim motors heating up, and when we got into third match in playoffs, we'd start browning out at the end of the match, even though we weren't driving any differently than previously.
Right.
So that was part of it, and also just from a geometry standpoint, it makes this whole thing possible because it allows us to space the center wheels properly.
Oh, okay.
So a lot of reasons to do it. It's something new that we're trying this year, but we like what it looks like, and
and the Party Parrot did not have that, correct? The Party Parrot was just for regular sims.
Correct.
Okay, so this is kind of a completely untested design for you guys in that regard.
Yeah, a little bit.
Okay, cool. Taking some risks. That's a good thing, though. So I also noticed those wheels aren't all in line. You've got wheels on the outside and wheels on the inside. It's kind of goofy. Why is it like that?
That's a little secret sauce for now. We'll talk about why we're doing that in a future week.
Everybody's got secrets. Jeez, sweet.
Secret sauce.
Okay.
There's 2 secrets still on the robot.
All right. Well, here's a good question. Now that you mentioned secret sauce, we got to bring up one of the important questions of the day. Does your secret sauce taste better on a burrito or a taco?
I myself prefer burritos.
Nice.
I can never get tacos to stay together. However, I recently discovered that if you take a hard shell taco, you split it in half, and you put cheese underneath it, and you put a soft shell around the whole outside, it stays together a lot better. So I'm still a very big burrito fan.
And then if you wrap that in a pancake, and then wrap that in a pizza, then you get okay, cool. All right, what about you guys?
747.
Landon, tacos or burritos?
Ooh. I'm going to have to go burritos.
Burritos? What about you, man?
Tacos.
Oh, okay. 2 out of 3 ain't bad. All right. So let's answer some really good questions from the chat here. We got a question coming in. This is from Hannah7. She asked, how's Apex finding the challenge of this build season in comparison to last year? How are you guys building off of the lessons learned from last year?
One thing that we definitely took off is how to communicate really well as a team, especially during the day of kickoff, to where we came back to the school and we had already read some of the rules, and we had the generic idea of what the robot constraints were. So we were immediately able to go, okay, we want to go tank drive because it worked extremely well for us last year. Then some of the team had been on board with the 3 mini sims, so we decided between those two things. And then also working with other teams has really helped us last year, because this drive train, it was made possible because a good friend of ours, Team 2056.
2046.
Oh my god. 2046.
I wish 2056 was a good friend of
Oh
ours,
my
but
gosh.
they're not.
It's all right.
My bad.
Bare metal. We know it's bare metal though.
Yeah.
Yes.
Allowed us to use a CNC machine to cut it, and then also building off of last season, we had a more successful fundraising campaign,
Yep.
and we were able to get a good amount of more sponsors, one of them being C4 Labs and the other one being Aerotech. And as of right now, Aerotech is cutting some of our parts for us, and then we're planning on going tomorrow to C4 Labs to cut some other customized parts.
That's great. I mean, that's really great, especially considering your school doesn't have any machine shop to speak of, or even a wood shop, really. So having those kind of sponsors really allow you to do a lot of awesome stuff. So let's kind of expand on that with another question. This question comes in from Big Bad Bob 319. Oh, how ironic. So given your success last year as a rookie team, what advice would you have for rookies for this season? Ooh. How about Evan? What are your thoughts? I know because
I think you can be successful focusing on any one of the main tasks this year, as long as you pick it and focus on doing it well.
Yep.
There's a place for you on pretty much any alliance, and I think that's really the key. Make sure you understand the rules really, really well, especially with regards to how to build your robot. And I don't know. Being a rookie is tough.
Yeah.
Even the team that had some really experienced mentors, there's a lot of challenges associated with it. Just knowing where the information is. I think the best advice that I can give is reach out to local veteran teams in your area, especially the more successful ones, and build a relationship so that you can go to them for advice and get help, and maybe even have a couple of them come visit your build space and look at what you're working on, and how they can catch problems early that as a rookie you might not even be aware of.
Cool. Well, that's great advice, guys. Thank you so much for joining us tonight. It's been a pleasure to have you on as always, and I can't wait to see what those parts are looking like, and I can't wait to see what that secret sauce is, because I'm actually really eager. So everybody who's watching live, thank you so much for joining us tonight on Check-In. We're going to be back next week, 7 o'clock, this time with sound. Same time, 7 o'clock here on FRC GameSense. Follow us and then on Twitch, and you'll get notifications, or subscribe to us on YouTube. You'll also get notifications exactly when we go live. So for everybody else on RoboSports Network, I want to thank every you for watching. Apex, thank you again for joining us, and we'll see you guys next week. Bye-bye for now.
Bye.
Bye.